Okay. Good morning, ladies and gentlemen. I'd like to welcome you to our session, Fighting Network Threats. I'd like to welcome you. We have selected, I think, 3 interesting presentations from colleagues from 3 different countries. We've got Cynthia Wagner from Restena talking about monitoring a darknet by a black hole. Then we've got Rogier Spoor from SurfNet. He talks about developing a code of conduct when dismantling or fighting a botnet and what you need to do if you find a packet of data, maybe collected by some people who were actually dismantling the botnet. And last but not least, we have Christian Keil, and he's talking about the Advanced Cyber Defense Center for Europe and common approach to actually detect threats in the network. Okay, first let me introduce you to Cynthia Wagner from Restena. She's working as a research engineer for Restena's CSIRT, and she's also working as a security team member of Luxembourg's domain name registry.lu, and also does some spare time teaching at the University of Luxembourg in computer network security. Today she's talking and presenting us her research that she has done with colleagues with her CSIRT and the national Luxembourg CSIRTs on monitoring darknets by a black hole. Cynthia, please.
Does it work? Yes, it works. Good morning, everyone. So, as already introduced now, I'm Cynthia Wagner, working for Restena. And this work was, in fact, initiated last year since we operated this black hole, where we said, hey, why not having a look into that one and just observing what is going on there? Maybe we see something interesting. And also to get a bit more details about what is happening in such a black hole. And actually, Restena didn't want to do this job alone, therefore we asked our friendly colleagues from the Circle, the National CERT of Luxembourg, in order to do this work with us together. So, the motivation of this work, as I already said, was the monitoring of unused IP address space, and we wanted to see if there is any interesting facts happening in that noise. And therefore, the topics that I will present today are some observations, maybe give you some reasons why there was traffic there, and present you some countermeasures, how you can avoid such observations that we made. So what is the void? So the void is it's IP dark space, so it's unused address space of a network. And arriving traffic here is mostly unidirectional, so it ends up in the black hole, and it is unsolicited because it is mainly traffic that ends up from attacks or from wrongly configured devices. So we do not really want traffic there. Of course, next question, is there any traffic in this dark spaces? Yes. And we will here talk about how it does arrive there. If it is on purpose or mischance, I can already say now it's on purpose sometimes, and it's also by mischance somehow, and give you some security impacts. So here we have a brief architecture representation. It's mainly a normal network where we have a sensor placed that collects the data for our darknet, and then we have the collector and the analyzer, which perform the main task of storing this data, which is quite complicated to explain now. So if you want to read more, just read the paper. I will run about it, and you can read about it. So the origins. Why do we have traffic here? In most cases, we can say it's from scanning attacks, like SSH brute force attacks, or it's backscatter traffic that arrives here, where backscatter traffic is simply traffic from spoofed IP addresses from legitimate hosts which are under attack. we have self-replicating code which arrives here, like the configure or other worms, so traffic that ends up in our black hole, but also from badly configured devices. And here I will put my main focus on it, like, for example, printers, servers, and other machines. And since our dark space is very well suited for spelling mistakes, since it is very close to RSC 1918 from private networks, so we can also say that spelling mistakes are a major reason why we have traffic here. So the data set that we have collected, so the probe is still up now, so we are still monitoring it and we are still capturing data from it. So for the moment we have 71 gigabytes of compressed PCAP files, which is already quite a lot. So, and on the left figure, for example, we can see the most probed subnets that have been where traffic is active on. So, and here we can see, for example, that the .100 subnet is the most probed one. We suppose that this is due to the fact because this IP address that is used for the dark space is very similar to manual and examples. So as people mostly copy from manuals or instruction books, we suppose that they have, for example, forgotten to change the IP address. Therefore, the most probed subnet is .100 because this is very similar to the examples IP addresses. On the left, on the right, sorry, we have the traffic which is represented, and here we can see, for example, over a period of 3 months, we have pattern in it. So it's like normal network activities. On weekends, we have less activity than during weekdays. So it's quite fun to see. Yeah, now speaking about the main reason of this presentation, the spelling mistakes. So in general, while writing or texting, 34% of all errors occurring in writing are omissions. So we simply drop one character. As I gave here the example for writing network, we simply write network. And another fact is that 23% of all errors happen on the third position of a word. When applying this to the IP address, this will give us the third position of the IP address, which in fact can be said that mostly this IP address also contains the error on the third position. And as a last fact, 94% of the spelling errors are single errors. So a word only contains one error. And this can also be applied to network configurations. So in our case, we define an IP address as a word where we say all digits in the IP address are considered like one character, including the dots. And the reason for the traffic in our dark space is that we have spelling mistakes, substitution or transposition errors. If you want, for example, to write 193 for your IP address, you write 139, or you want to really to write 139 and you write 193. So therefore, we have normally the error on the third position. Another assumption is also to have two errors, which we made, but only 6% of all words in writing or in literature. 6% of the words have multiple errors, and they must have a general length of more than 7 characters in order to have a second error in it, which will fit in IP addresses, for example. For the moment, we are still in work in progress where we want to do a prediction model for spelling mistakes in network configuration. So we want to set up a mechanism for detecting if we really have a spelling mistake or it is there on purpose. So, but it's still under submission, so I will not give further details. But for the more practical part of this presentation, I will give you the observations now. So here, for example, we see the S numbers from the traffic that arrived on our network. As we can see, there are some ASs marked in bold. And here we can say that all those marked in bold are from China. So why do we have so many AS numbers from China? Well, once we can say the proportion of activities versus the number of hosts in China is very high, therefore we have also a lot of activities there. And on the other hand, we can also say that the Chinese Great Wall Project or the Golden Shield Project from the Ministry of Defense of China does not really filter leaked packages. Other traffic that we had here were the DNS queries to resolve antivirus domains. So what does this mean? In fact, we extracted the DNS queries for these antivirus domains, and it was proven that we looked them up, and those that did not match, we simply said, okay, they were badly resolved. So in most cases, resolvers were badly configured, and the lookups that were resolved here mostly were for the subdomain avts.mcafee.com, which is the intelligence program of McAfee, and information from users is sent to McAfee in order to check if a file is malicious or not. So as we can see, a lot of traffic, a lot of resolver had wrongly configured IP addresses, so the domains that were looked up were not existing. Another observation that we made was on certificates. So a lot of queries was for revoking X509 certificates were performed. So as we can see in the picture, for example, many requests were sent during September to December. And this was, in fact, a migration period of certificates. There was no support given anymore for 1024 keys. So therefore, a lot of certificates were revoked and so on. And on the other hand, a major reason why we could have traffic also here was a security flaw in Microsoft certificate, which was fixed and a new release were performed. So there we could also observe a lot of queries going to a Microsoft domain that did not work. Yeah. Logging information in the dark space can also be observed because we can have a lot of spelling mistakes during our configuration. So, and this can have, of course, many undesired effects. We can, for example, disclose sensitive information about our routers, our user passwords, and so by syslog and SNMP. And this can have unwanted effects later on, because information that is already enclosed in such kind of messages, even if I don't show everything here, you have the IP address, you have mainly the company domain name, the host or the username, but also you can have passwords and additionally the configuration commands that were prompted. From the other side, for network reconnaissance, which is also a part in an attack life cycle, a step in the attack life cycle, this can, for example, be used for any social engineering attacks later on. So NetBios and machine names can also provide you precious information for this kind of reconnaissance step. As we can see here on the left, we have some machine names which tell us about what kind of devices we are using. And on the right side, we see NetBios machine name types, if it is a workstation, a server, or a domain controller, whatever. As I said already, social engineering is a major issue here in these spelling mistakes because it is the task of collecting information about the potential target. So you build up your attack scenario by comparing this puzzle of data. So you get the NetBios machine names, you get information about the machines, the company, and so on. You can Google for additional, You can Google information about potential targets. And therefore, you can set up a major, easy scenario for getting into that company, like, for example, by simply pretending to be a maintainer of a system and you coming from a company X, and you have to do maintenance work on it. some security recommendations that I can give in order to avoid such spelling mistakes in configuration details are, for example, you could check the spelling mistakes or even double check if needed. So have a second person in place that could also check those configuration details such that not everything is leaked outside and that your data really arrives there where it should arrive. The leaking of information, you can restrict outgoing traffic, for example, with firewalls and so on, adjust the logging levels. So you adjust the logging level to a low level of logging simply in order to see what traffic is leaked and which one not. And of course, for a lot of different tools such as an MP and so on, you can use encryption. It is really supported now in most tools, and then your passwords and your user accounts will not be leaked simply, but it will be encrypted. So this will in fact lead to social engineers that will not keep your data then. From the DNS part, I can only say that you should have more name servers configured, because one simple DNS server in place is not then enough. So traffic can be leaked to an attacker, or for the certificates, they can be modified by attackers, for example, and they reply to you back such that your certificate still looks like it is valid, but it's the attacker that sends you back that your certificate is still valid, but in fact it isn't really valid anymore. So filter the connections, set up a filter policy such that not all connections are going to the outside. Log DNS traffic in order to see what your DNS is doing. For X509 certificates, ensure that your browser supports CRL and verification. So most browsers support it, and if you are not sure, audit the software by performing a revocation, or simply use a traffic monitor tool to, like Wireshark, for example, to see what really is going on. Yeah. To conclude this, I would say that information can be leaked to misconfiguration in devices or even in DNS. It is everywhere. And most errors that we really observed were copy-paste errors from manuals. So therefore, we had the traffic in our black hole. Data that is captured in those black holes can be used as an attack vector, since it provides us precious information about a company, for example. In fact, the whole presentation here that was given was to raise awareness so that people shall check what they are typing, and also check what they are doing, or even double check what they are doing. So as the security recommendation globally, I can only say that verification of this configuration files is essential, but also the monitoring and the level of monitoring that is in place should be there, and should also cover critical services, because also in our observation we had some observations made about critical services which shall not arrive there. We had to contact other certs in other countries to inform those people that there are devices which are out of scope, let's state it like that. So, and to really conclude this presentation, I would like to say that cybersecurity data-based monitoring is important to have it in place. And in now and in future, I would say that it is also a part of early IT warning systems. Okay, thank you. Any questions?
Thank you very much, Cynthia. Thank you very much. Are there any questions from the audience, actually? No questions. Well, I have a couple of questions. Anyway, do you reckon that this black hole or darknet monitoring is still relevant when everybody uses IPv6, or is the address space too large, or?
Actually, we have not tested it on IPv6 yet, but there are a lot of work already going on also in the monitoring for IPv6 address space. So.
Okay. Questions from the audience? Otherwise, I have another question for you. How likely is it, or could it be that malicious software on compromised hosts will actually mess with the etc, with a host file there, with the DNS resolver, to direct any traffic or name resolution into the void? So that, for example, OCSP or requests for OCSP responses or CRLs won't receive the proper CA servers, just end up in the nirvana, and the browser never gets an answer. So can you make an estimate? Is this possible?
Yeah, I would say it's possible. So also there were some observations made where, for example, hosts tried to access iTunes, but in fact what was returned was in fact a phishing website. So actually, and since this phishing website was not active anymore, everything was transferred to the black hole again. So we had some observations where hosts also ended up in the nirvana.
Okay, thank you. We have a question there, Andrew. What? It's coming. Just a second.
It's coming.
I'm quick.
Thank you. And Andrew Cormack from Janet. I love the idea of trying to work out whether common spelling mistake patterns apply to IP addresses. What it struck me was you then listed China. I thought, wait a minute, I don't think they write left to right.
Yeah.
So I might tweak your third character test to try and look at reading writing directions.
Yeah, that's
and
true.
I'd be fascinated to find out what happened.
So any other questions? There, and there.
Hello, Alan Buxley, Loughborough University. I was wondering, are you looking to see who are using RFC documentation space for their live servers and systems? So people have just copied verbatim documentation.
Yeah. Yeah, so it's, in fact, the IP address space we are using is very similar to private network addresses. So therefore, you can already see in the configuration details, for example, of devices, that people were simply copying from books.
Okay, I think we had a question in one of the rows here.
Yeah. Pobelka from Cessnet. I don't know, are you aware of Labria project? It's a kind of honeypot which sits on unused IP addresses and detects connections to these addresses.
Yeah.
This thing already exists. Do you know that?
I know about it,
Are you able to guess, based on your research, how many connections to these unused spaces are in fact bogus, and how big percent might be really malicious?
Actually, we do not have, we have not made any further research on that, so I have to disappoint you.
Never mind, just right, thanks.
Okay, any other questions from the audience? Seems not. Okay. Thank you very much.
Thank you.
Cynthia. Okay, now our second presentation will be done by Rogier Spoor, and he's talking about Surfnet's development of a code of conduct when dealing with dismantling botnets. Rogier works as a middleware service manager in Surfnet, and he's looking at developing services in the security network space, cloud computing, cloud storage, personal cloud storage. So, Rogier, it's yours.
Okay.
Thank you.
Thank you very much. So one of the things I do is I help our security community called SCIRT. It's a very active community in the Netherlands where we have about 210 people in which we organize meetings. We all talk about security incidents. So we had a very nice weeks about Heartbleed last, 1.5 months, I would guess. Very popular topic. This presentation is about codes of conduct. And the reason why we developed codes of conduct, and they are currently still in the draft version, is that we were helping researchers actively by taking down botnets. Most common, we didn't ever tell anybody we were involved in that process because we were a bit afraid we might got hit by very severe DDoS attacks. But suddenly at some moment we decided we need to have more policies, in particular when we were involved in the process about returning back the data. And for me, from a private person perspective, I always thought it was very, very strange that when I'm at home and when something will be stolen from my house, my bicycle or whatever, and somebody else will find it, he will probably return it. But if you look to the internet and somebody breaks in, well, a lot of PCs are getting infected by botnets, they steal a lot of data, but who is going to return it? Who is informing me what kind of data is on the streets? For me, it's just like that the bad guys can easily obtain all the data, but we, the good guys, we are handcuffed somehow. We can't do anything useful with it. It's a bit of, strange, and we thought we should have a procedure in how to handle the sensitive data. I mean, it can help defining security processes within institutes. It can also help end users by informing them what kind of data was actually on the street. I mean, a lot of people, they get emails from their ISPs that their machine, their IP address was infected, and then sometimes you get it was infected by this and this botnet, and you should assume that every credentials of yours are stolen. But then the question is, does a private person, will it change all passwords? What does it need to do? That's very difficult, and it can sometimes help in providing some additional information. So that's the code of conduct all about. So something about history. How do we usually work from history with notifications about infections? Usually it's a reliable source, so how we call it. A reliable source is notifying us that they have seen some infected PCs that are within our autonomous system. We just usually alert our constituents, and we will provide them with information about IP address and timestamp, and sometimes also about what kind of infection it was. So usually the institutes clean devices. Incidentally, we are involved in something like sinkholing, but there is no knowledge about which data was actually stolen. And I think for most organizations that's the way it goes. So actually I think the internet has changed a lot. Nowadays, everything must be secure, more reliable. Banks are depending on the working of the internet. The interests are much higher even within universities. Think about patent research, that they make also a lot of money from it. You have the academic hospitals that, they want to know if somebody breaks in, if patient data was really stolen, yes or no. And one other thing is that they like to improve their security policy, and it can help providing them additional information about which data was actually stolen. And I'm still saying stolen. What I actually mean is that the bad guy took a copy of it. Yeah. So, process of returning stolen data doesn't exist, and one of the key questions is who owns stolen data? I mean, the legitimate holder, the owner of the data, didn't ever, state that it was okay, that it was taken or copied actually. So then the question is, who owns? And how can you return it back? Do we need to have some consent from the creator of the data or not? How can we process it? I mean, if you get botnet data, it's it's a blob of data. It's unstructured. You're usually not aware how it's structured. So that's a bit of a painful thing. So you need to examine the data, and then you will obviously also see some private sensitive stuff, and that is an issue. If you look to the EU legislation, well, this legislation about privacy, it was all meant to help the user in relation to providing data to, well, commercial organizations. But in this law, there's nothing about if data gets stolen, how to handle it then. So how we were triggered in this, I think about 1.5 years ago, I got an email from an unknown third party mailing me, I have a lot of private data from most of your constituents, and I offered it to the police, but the guy said, I offered it to the cybersecurity center, but, well, those organizations didn't have any procedure, and their lawyers told them, don't take it, it's tricky, don't take it. So they were, keeping their hands off of the data. So then this person came to us, and at first sight I thought, well, why not? Give me the data. I would be interested, and maybe we can do something useful with it. But then I spoke to our lawyer, other people, and then I knew, okay, this is more tricky. I can't just state, give me the hard drive, give me all the data. That's tricky. So we thought we must do something different with it. For one of the questions we had, can we accept the data? What about the law? We are in the Netherlands, Dutch law. What is saying about this? Other questions are, how reliable is botnet data? I mean, how do we know if it's accurate? Yes or no? How can we process it if we will get it? Can we look into it? Can we extract stuff out of it? And how reliable is the source was also a question. How did he get it? There were rumors that he broke in the server and got the data. One of the things was he was a convicted cyber criminal, so that made it also a bit tricky to, are you doing business with somebody or business? Well, he was just offering it without any restrictions, but it made it more sensitive. So the approach we have taken at that time, and we didn't have much time to have lots of discussions with lawyers and so on. So we just alerted our institutes that stolen data was available, and we at first sight only gave them information about IP address and timestamp, just the usual procedure we have. And then we said, okay, if you ask within 3 months of time additional information, we will put you in contact with the person stating that he has the very sensitive part of the data. So we as SurfNet, we were only connecting, basically the security officer and the person having the additional sensitive data. So we didn't see we haven't seen the data ourselves. At that time we had some questions about this process. One of the things was that we were connecting the third party with the security officer we knew within the university or polytechnic or other institute. And the question is, does this security officer has a mandate from the board in order to be able to process the data? I mean, this wasn't something what he was usually doing, and and actually the answer to the question is we don't know if he has a mandate, yes or no. So we knew for future cases we should do something in order to make sure we know he has a mandate about this. Some other thing is, does the institute have a privacy regulation? How are they going to process the data? Is it just the security officer diving into the blob of data, seeing a lot of private sensitive stuff? Or does this institute have a very good procedure about how to handle? And we have also seen many different ways, different procedures that institutes have taken in order to process the data. So what were the lessons learned after this data returning process? Well, the importance of returning data differs a lot. So, for instance, for academic hospitals, they just want to be sure there's no patient data leaked. On the other hand, if you look to education institutes, well, I don't think the importance was that high. Many universities told it was interesting in order to have a view at the current security procedure in order to, well, fine-tune it better, but they stated also that it was not really to have such amount of data every time it would be available. So the data was unstructured, so somebody has to dive into the data. That was a problem. Yeah, and the problem is you can only value the data after you have seen it. And for us, as the ISP, it's very difficult to value the data because we don't know what the institutes are doing internally, so it's kind of difficult. So policies of institutes differ a lot. So basically, some institutes state that private internet usage is not allowed, but most of them allow private usage of their network. That basically means that if a user is in the university, he will also do private things, so he will also create private data that is non-related to the institute. And so if you're returning back data, you should be aware that a lot of real private data is in there. And that's, well, that things like ethics is also important there. How are you going to do, how are you going to handle that? And I think in particular, if a university, for instance, gets the data back, they should be very aware about the process in which they will handle the data and investigate it. So the data handling process of university was quite new. Some of those universities shared the process, and we shared them with other institutes so they could improve their process. And well, it's just a matter of that they have a process in which they define that, for instance, if that a certain person is looking into the sensitive data and he sees a name of a colleague he knows, that he should immediately stop watching that data and he will hand it over to somebody else who we might continue or not processing that specific part. From ServNet perspective, it's important to know in the future if the security officer has a mandate, so we should have in the contract something that the security officer is allowed to, well, ask for additional private sensitive data. We have seen in the data that due to VPN usage, so a lot of users are at home connecting to the university, for instance, and then the university IP will in the data, but actually it's private data of usage at home. Check for patient data is very difficult to automate. Well, and from privacy, the criminal law perspective, we had many questions. So that's why we asked two professors, one professor about criminal law and one professor of privacy law, to write an expert opinion about how we should, well, what we should do in future. So we could define a policy out of it. One other reason why we needed a policy is that after this Pobelka botnet case, we were contacted in order if we would like to help in taking down a botnet. But in this case, we could also collect a lot of sensitive data by taking the botnet down. It was a peer-to-peer botnet, and it was an IP address within our backbone. We could take down the botnet by, well, by help of the researchers, by manipulating the peer-to-peer traffic. But we could also very easily collect all the data that would be gathered in that peer-to-peer network. This was very sensitive in the sense that then we should be, well, really actively getting very private sensitive data, and then we thought, okay, we should first wait before we have a policy about this topic. and then we might continue, but not on forehand. So, hereby a few slides about the professors, what the professors told us about the criminal law in the Netherlands. Well, first, if you want to take down a botnet, it's not directly illegal. It will depend. I think in general, if you talk to a lawyer, you will most often get the message, it will depend if it's allowed or not. So, but I thought this is good news. So it depends, it means, well, it can be. Proportionality, depending on what the botnet does, you can take some active measures in taking it down. But for each action, always the question will be, should we do it as NRN? Should the police do it? Should the institute do it? Well, we should always think about that. The other professor wrote a paper about privacy perspectives. And the privacy part is the most tricky part. So I have 3 slides about it. So first bullet is that he states that you may process sensitive personal data in order to increase the security. But before you do so, you need to define on forehand very specific goals. You can't just say, okay, give me the data, I will have a look on it. And beforehand, you have to specify your goals. So what are you allowed to do with the data from a privacy law perspective? Well, you may warn concerned that the computer is infected. You may alert third parties about that the botnet is, for instance, attacking a bank or so, then you can inform the bank. And you may inform the institutes, our constituency, about what's happening there. And you are allowed to take measures to reduce the activity of the botnet. But you must destroy the data as soon as possible, and you should anonymize it as much as possible, which is obviously very difficult. So, well, we are allowed to give the data to the institute. This is also because we, as an ISP, have a caretaking role. We are the ISP. If we see something, we should help them. In this role, we are able to provide the data. It is defendable that we would transfer data we would get from a botnet to the investigating authority. And I know that some people are, well, disputing about, well, should you do such a thing? Or when should you do it? But anyway, it is defendable that if you get it, you are able, or you could give it to the authority, so then they could, well, start a case for the police. So, and we may warn internal victims, obviously. As much as pseudonymization, anonymization is obviously important, and when we will define policies, we should discuss this with other ISPs, the privacy authority, the high-tech crime center, etc., in order to have a very broad agreement about that such a policy is the way to go. So last 2 slides are about the policy. So there we have 2 policies. One is about when will we proceed with active botnet takedown. Well, first you will define the importance and the impact. Why are you going to take it down? Is there really a need? You will inform third parties. Nowadays there are quite some organizations already monitoring botnets. So if you're as a organization going to take it down, it's rather, well, you should inform the organizations watching or monitoring the botnet. You should also contact your organizations, your universities, about that you are going to do such a thing. And dependent on the impact, you should on forehand ask them for consent. Then perform the takedown, if very private sensitive data will be collected, well, you have to, well, define the importance of returning the data to the potential owner, if you can find it, and you can hand it over to the police. And last, you should write a report about it. To be honest, this policy about takedown, we have been involved a few times in actively takedowns, and well, lessons learned is that it is not that interesting, I think, at the moment to actively take down botnets, because last time we were involved, it was about 1.5 years ago, we just saw that within a week or 2 weeks, the botnet was fully up and running again. So then the question is, if you can take it down, yeah, does it really help you if it's when it's up and running week, 2 weeks later? I don't think so. So the only reason why I can imagine in taking it down is that there is so much, for instance, like there's a very heavy DDoS, you can't mitigate it. That could be a reason why we should actively take down botnets in future, but if else, I can't really imagine why we should do such a thing. Last slide is about the draft policy we have created about returning the data. The data we would get from the botnet. We would first define the interest and the impact. So the question will be, well, why? Why are we going to do it? We need to have guidelines. Sometimes we need to really see the data before we can define how important it could be from an institute to get the data back. We might have an external committee checking if we should proceed with the procedure. And if there is sufficient interest, we must formulate the goals beforehand and do a report on the privacy authority in the Netherlands. And when receiving or making available of data, well, first, the importance and impact, as I told. Next, it is important to be able to distinguish between the user and the IP address. I mean, if you want to, well, give it back and there is no really relation between the data and the IP address or a computer, then it's very, very hard to, well, contact the right person, for instance. And if the data is old, like in the Pobelka case, it was already sometimes half a year old, then for many organizations, it's really difficult to connect an IP address with a person or a computer. So at that time, it's also, well, you should think about how useful it is then. In the procedure of returning, we would always first give an IP address and timestamp information to the organization, and then ask them if there is really need to have the additional very private sensitive data. And if not, we will just destroy it within 3 months' time. There's also a data breach law coming, and we have to inform then about the data we would have gathered. And when it's finished, and we will obviously destroy the data. So this is the draft process we have created. We are working with the Tilburg University in order to improve our policy further this year, and we will also publish an English version later this year. So far my presentation, and I'm happy to answer any questions.
Yeah, thank you very much, Rogier, for the nice and interesting talk. Are there any questions from the audience? There must be, I think. Andrew.
There was, which was, when is the policy going to be published?
Yes, I had that question as well. Is this the policy? There's a longer document.
Yeah, there's a
isn't
longer
it?
document.
It's not just the bullet points. Okay.
Yeah.
There is. I did write a theoretical paper for TFC, so it would be really good to compare your experience.
Yeah, sure. Yeah.
Any other questions from the audience? Okay, So what do you think? How likely is it that you could actually take your policies and apply them in other EU countries? I mean, obviously there's a Dutch lawyer involved, so that'll be completely different but similar, I hope. But
that's a difficult question. But the good news is, in general, with lawyers, they will always state that it will depend. And that's always that's what I see as the nice thing, because if you look to the law and the European law, it was never intended to do something good with stolen data. And then on your end, as an ISP, you have to take care for your organizations. And because of this caretaking role, I'm very confident that you can do something good with it. And it will just depend per country how far you are going to, go in that way. And I think it's very important to have the discussion in each country about, what you can do and how far you will go. But this is a very new topic, I think, and difficult to.
Sorry, Andrew Cormack from Janet. To support, I would be horrified if you didn't get a positive response from your national authorities. ENISA have had a series of working groups on information sharing, and that has included CERTs, police, and privacy commissioners. And the privacy commissioners have been the ones saying, come on guys, this is important, do it. So they are worried by the amount that our processes are getting in the way.
Okay.
And they have, even more strongly, the comment you had from your lawyer of CERT work protects privacy, it doesn't invade it.
Yeah, okay.
Another question.
Just a quick thing. There's also the MAXA effort, the NATO thingy around information sharing. I think they'd be really happy to hear from you. I'm happy to point you in their direction.
Yeah, we can. We'll be very welcome.
Yeah. So just Roman Vattel from CERN. So just a comment to highlight the importance of international collaboration there, because I've rarely seen a botnet that is only affecting one country. So it's usually multinational, and it's very important that all the certs talk together. And currently there are various frameworks you can do it, but none of them are legally proved, and that's very difficult. So I appreciate the work that Andrew Comeback was mentioning earlier on, but I think it's still very difficult, and we're still a long way to go before we can have a procedural policy that applies to multiple countries. I mean, usually what happens is that someone in one country decides to press charges or something like this, and then you collaborate and you do everything you can to obey by the court of law in the country that is decided to press charges, but that's not really scalable. That's very difficult.
It's very difficult, and on the one hand, you don't want that people are going to put data on pastebin, because then sometimes putting data on pastebin is some kind of a way that other countries can use it, because then it's in the public. But that's not the way how we should handle this data. It's much better if we can define processes in between countries, between certs, etc. Yeah.
Okay, any more questions?
This is just a comment. I'm David McLaughlin from the Federal Institute of Technology in Zurich. And our Federal Data Protection Office, I actually approached them about a legal clarification about how do we handle data and what are we allowed to log. And they gladly provided it, but they were utterly surprised that somebody ever came and asked them. And I would have thought the legal authorities, especially the data protection authorities, they should actually be kind of proactive and contacting institutions, and ours, they don't seem to do that, which was a surprise. Anyway.
Yeah.
Okay, there's another question here.
This is Noor from Dante. I have a question. Like, whenever the machines are compromised, they are usually misused by hackers for multiple companies. Like in phishing, if there is a hack machine, the hackers usually use those machines to collect data from multiple banks So how will you identify like which particular banks are involved and how to provide that data? Because it could be a simple text file containing usernames and passwords, but usually hackers have their own techniques, like first or second rows are for particular banks or second file for another bank.
Our focus is so far only based on IP address and timestamp on first hand. So like bank information, well, we don't, if you, in the botnet data we once got, I knew there was also bank account stuff in, but we can't, well, easily see which bank it is. And we were only checking the IP addresses of our constituents. So, not more. So we didn't do anything with bank information.
Okay, thank you. Any other more questions from the audience? Doesn't look like it. So thanks again, Rogier, for your nice presentation. And I think we're going to finish up with a presentation from Christian Keil. He's working with the DFN CERT in Hamburg. He's a principal researcher there, looking after network and computer security, looking after DDoS attacks, botnets, sensors, and early warning systems. Christian, please. It's your turn. Go ahead. Tell us about the Advanced Cyber Defense Center for Europe, ACDC.
Exactly. Thanks for the introduction, Reimer. And actually, I'm quite happy to be in this session with these great talks before me and with the questions from you indicating how much this topic really resonates with you. The thing that I'm going to present you is as you see here on the slide, ACDC, and no, I'm not going to drop any further musical references on you besides that one. So the target of the ACDC project is really to detect and mitigate botnets, and that on a European scale for now. And where's this? Yeah, I'm pressing the arrow, but oh, here it's going. Okay, so first of all, I'd like to give you some impression on the versatility of botnets today, which probably many of you in here already know, but just maybe for some things that you don't know to have a view on this. Here we are. First of all, a really big topic in botnets is, of course, DDoS attacks. And these are numbers that were from a campaign that was running sort of beginning of last year until middle, third quarter of last year. It's the It's Okay, No Problem, Bro, which was a campaign infecting servers and using their larger bandwidth. So this was the next to last thing in DDoS attacks in last year. And they were mainly targeting American banks at that time and easily produced traffic on the order of 100 gigabits per second, attacking their targets. And the latest thing that we already saw in some other presentations were these reflection attacks that easily reached 400 gigabits per second. And while these later ones, since they were reflection attacks, they were probably not performed via botnets, but just using spoofed traffic. But certainly this shows that also botnets can use these to achieve similar traffic. So DDoS is one large aspect of botnets. Second one, large one, is spam, of course. While email spam seems to be declining nowadays, these are some numbers from statistics by Symantec and Kaspersky from beginning of this year, and they still estimate 70% of email to be Perfect, thanks. They estimate currently 70% of email to be spam, and most of this is actually sent by infected machines, so by bots. Next thing, malicious websites. There's the question, how are machines infected joining a botnet? One large topic here is infected websites redirecting their visitors to different exploit kits and infecting them via this. This is a study by ESET that was published in March of this year about the Operation Windigo. It was in the first instance detected by a SSH rootkit, which was called Ebury, and in January 2014 they saw something like more than 700 web servers infected with a large turnaround, so the actual number of infections is still larger than that, and they had approximately 500,000 visitors each day redirected to exploit kits to make them join said botnet. And going from the server side to mobile bots, of course, this is a emerging topic, and these are just some numbers from botnets that were detected on mobile devices. So one of these sending out 500,000 spam messages, SMS messages per day, and another large thing in there is using premium services to really turn these mobile devices that are infected into money for the botnet herder. And this is usually done via texting some premium services that you have to pay for when you use them. And this is just one of these, earning the owner of the botnet something like $3 million a year, and they have currently something like 66 countries supported, which means that if you want to use these services, they are usually targeted towards one country. So you have different numbers depending on which country you're in. And they mostly started somewhere in Asia or Russia, and nowadays they evolved, adding more and more countries, and this is quite global now, with Europe in there, with USA in there. So that would be a good slide to play something like Highway to Hell. Now, after this introduction and these numbers about botnets, I'd like to present you the thing that we've been working on together with several partners for approximately the last year, which is the Advanced Cyber Defense Center for Europe. Just a couple of numbers. This is an EU-funded project inside of the FP7 program. As I said, it started in February last year, and it's running until July of next year still. And one important thing about the character of this project is that it's a pilot project, which means it is not research, but the focus of all the projects that are in this FP7 program, at least for this call, is that they have to integrate existing solutions and only to a limited extent, a very limited extent, really perform new research. But the aim is to have, at the end of the project, a running pilot, a working pilot that really is able to achieve its goal. ACDC in total consists of 28 partners from 14 countries, so this is quite a large group. And we have different stakeholders in there. We have ISPs in there like Telefonica, Telecom Italia, ECO. We have CERTs in there, as we are. We have FCCN from Portugal. We have Inteco from Spain. We have IT providers in there like Atos, for example. We have NRENs, again, FCCN from Portugal. We have Carnet from Croatia in there. We have academia. We have the Fraunhofer Institute for Information and Communication Technology, the TU from Delft, the KU from Leuven. And we also have critical infrastructure operators like Barcelona Digital or BG Post. So as you can see, we have a really broad spectrum of parties in there collaborating for this common goal. And the concept behind ACDC is really starting from the beginning and going the whole botnet chain, so to say. So we start with detecting botnets, different sensors set up that provide data, that collect data. This data is centrally stored and analyzed to extract actionable information. This information is distributed to the affected parties. And finally, there's also some mitigation and prevention approach in there. Looking at the general architecture, and I'm going to give you a short overview of this, as there's really a lot of information in there, and I'm trying to give a high-level overview in the time that I have here. So this is the architecture that we have. First, we have sensors in there that collect the data, and as you can see on the bottom of the slide, these can either be connected directly to the central component, or it can be connected via some concentrators, where these concentrators can, for example, do things like pseudonymization. So if you have in your organization some sensors set up, you can send the data via some concentrator that anonymizes, pseudonymizes your data space, your network space, and forwards the data only then. Right now we have a concentrator working with the STIX data format, so everything STIX related can be pushed in there, processed, and further forwarded to this central clearinghouse, which is really a one and only one in this project. So there are no multiple instances of this, but one central component that aggregates, correlates the data, and finally forwards these to the national support centers that take the part of supporting the affected parties in mitigation and prevention. Also the internet service providers, and as you can see there, there's also, again, a component of anonymization, because we also have a interface, for example, for research activities, where you can obtain data in an anonymized fashion that is in the clearinghouse to make further research on this. Going towards the individual sensors that we have in there, we have one sensor for for malicious and vulnerable websites. As you can see on the right-hand side here, there are different components of, in this case, malicious websites, so websites that are already infected and redirect you to some exploit kit. So there are really different aspects of visiting such a website that you can use to detect. And this is just a collection of the tools that are inside of the project. Starting with the delivered content. So if you visit the website, what is provided towards the visitor, this can be analyzed. You can start analyzing it via directly accessing the source code of the website and checking what is in there. You can have sensors placed in a network and working on the data that is transferred. You can have sensors running on devices, checking what's happening on the device if you visit some website. And finally, you can, of course, also use something like reputation data. And these are tools for detection as well as analysis, and there's a workflow established where these tools can iterate. So you may visit a website, get a redirect, get a document. This document will be analyzed by another tool that is analyzing, for example, a PDF, may extract an exploit, may extract another URL that you're redirected to. That URL can be fed back again into some honey client visiting the website and checking what's happening there. So these are really cooperating for detection and analysis. Then we have sensors that are used for network traffic. So these are tools that are placed inside the network of some partner, of some party contributing to the project. And these can be something like honeypots running in the network. This can be something like darknet, for example, where you can forward the data to the clearinghouse. It can be something like NetFlow monitoring or deep packet inspection. And the third group of tools that we have in there are end customer tools. This is either software running on the device, running on the hardware of the end customer, which may be running on his mobile phone or which may be running on his desktop, for example, as a plugin in his email program or in his browser, but also as plugins for example, webmail, so plugins for software that you use via the internet, plugins for webmail, plugins for blogging software that you can, easiest example is, for example, forwarding spam to the clearinghouse to extract more information on campaigns and infected machines there. Then we have this central component of the central clearinghouse where you can see that the data from the sensors is forwarded to. This is really collecting, analyzing, and extracting data and also distributing it. We have a quite diverse set of data formats that is accepted by the clearinghouse, so there is a limited amount of work to be done for different sensors to forward the data. And of course, we need to have some kind of access control on the data because we have a large collection of stuff in there, and we don't want to have everybody accessing the data and just taking it out there. So there's access control provided by a community portal that I will show you in a second. And right now we have a couple of million records in the clearinghouse, which is not yet that impressive, but the number of data that we have in there grows with each day, with the partners submitting new data. And at the output of the clearinghouse, so to say, and this is the component for mitigation and prevention, especially towards end customers, we have the support centers that provide information and disinfection tools. On the right-hand side, you see the map of Europe with the partners that are, with the countries where partners are inside of the project, and the dark blue countries are countries hosting or planning to host a support center. So as you can see, we have 9 support centers there already. The requirements for these support centers are quite scalable. So the minimal set of requirements, so to say, is just setting up a website, providing this information and tools for end customers, but this can scale up to telephone support 24/7 to help customers in disinfecting their systems. Right now, at this moment, we have 6 of these support centers already up and running in Belgium, Croatia, Germany, Italy, Romania, and Spain. And the remaining 3 are to come during the next year, more or less. Now this next component, the community portal, which acts as a kind of front end for the users of ACDC. So it provides you with access to the data, managing the access to your data. It allows you to specify policies for data that you share. So we have things in there like I'm pushing data into the clearinghouse, but I don't want that data to go to my competitors, for example. So you can really have a fine-grained specification on whom you'd like to share data with. If you do something like that, for example, excluding your competitors, then this policy is always used in both directions. So you cannot just benefit from just take data out of the clearinghouse, but not provide any substantial value to it. And one thing that was quite recently introduced and that we think is quite valuable is we have an integration with the Trusted Introducer accreditation. So with the collection of European certs, more or less, and the teams that are accredited there will automatically have access to the clearinghouse to query the data from their constituency. So in the Trusted Introducer project, there is a already validated connection between certs and their address spaces, their autonomous systems, and this data is used in the ACDC project to make this connection such that the party querying data from the clearinghouse can only query data that it is responsible for. And third thing, this community portal is used to share information and knowledge between the partners inside of the project. So this is a collaboration aspect in there. Of course, such a project, such a solution cannot be complete without validating that it's working. And this was also part of the call by the European Commission, that the solution has to be validated by different so-called experiments in there. And now you see probably again the connection to the first slides that I presented to you with the different aspects of botnets, because this is the set of experiments that we decided on in this project. This doesn't mean that other stuff is out of scope, but it just means that these are the things that we have to show to be working at the end of the project. And it covers the first aspect that I showed you with DDoS, spam, malicious websites, and mobile bots. And the final thing that is in there is fast flux techniques that are also very common in botnets to hide the individual, especially the controlling structure of the botnet, to hinder mitigation and to hinder takedowns of botnets. So, coming slowly to the conclusion of my talk, I think maybe the most interesting thing for you might be how to profit from ACDC. And the most valuable thing for you is probably becoming a member of the project, which means you will be able to query the clearinghouse on data. You will be able to exchange intelligence with the ACDC community. And you will have the opportunity to access technology or get your tools run. So, for example, you have a network and you want to use this network to collect meaningful information on infections. Accessing the ACDC project allows you to obtain tools by the other partners that they have developed that are working to run in your network and provide data from there. But also the other way around. If you have some tool but you lack address space or capacity for a large installation, then introducing your tool via ACDC into the project allows you to access, in a certain sense, the address space of the other partners to get your tool run and to get first-hand experience of the data that you can collect there. And also, as I said before, we have an interface that pseudonymizes or anonymizes, depending on the exact circumstances, the data. So via this project, you have the possibility to access a real-life, constantly updated, hopefully high quality and large data set for research on botnet data. Since we're now in the middle, more or less, of the total runtime of the project, all this is not open to the public yet. So becoming a member, you would have to wait for a couple of months still. The possibility that is there is signing a letter of interest, which is basically some kind of NDA, and which allows you to have early access to all of this, which also allows you still to help tune ACDC to your requirements, help us to build the solution that really helps you, and also participate in the experiments that I showed you before. So having first-hand access to all that is happening there. This is the website of the project. So there you can find all the contact information that you would need to get in touch with us, to help us tune the solution to your environment, to your requirements, and get in touch with us to join the project. Of course, the other way around, my call out to you, and I should have put this picture of the, from the, I think it was from the American military, we want you. How can you help us? First and most important thing is provide data. So if you have sensors running, if you have network space, we need the data inside of the clearinghouse. As I showed you before, you can specify policies, you can have anonymization or pseudonymization of your address spaces. We're only interested in the infection part. Help us to help you, reach out to us, give us your requirements, give us your thoughts, give us your feedback on the solution. How can we improve? How can we make this really valuable to you? And finally, of course, join the community, collaborate with the other ACDC partners, and make this community live and effective. That's it from my side. I thank you for your attention, and I'm looking forward to your questions.
Yeah, thank you, Christian. Very nice talk. Thank you. Are there any questions from the audience? Yes, Romain.
Hi, so Romain Wattel from CERN. So I have the same comment than on the last presentation. I mean, it's all very nice, but the botnets are not European only, unfortunately. So I would like to ask you about your plans to reach out to the US and the Asian countries. I mean, is this something you've considered?
Of course, in the context of this project, since it's EU funded, there are only partners inside of the project now, inside of the consortium, that are, no, not only. Most of the partners have their headquarters have to have their headquarters in the EU, because otherwise they won't get funding for it. We have Microsoft in there as a contributing partner. So we have that connection to the US there already. We reached out to, I think it was either Japan or Korea. So we have already reached out towards Asia. And of course, the view is to further enlarge the community there and to go beyond the European borders, because exactly as you said, this is certainly not a national and certainly not a European problem.
There are definitely organizations in the US, for example, like REN-ISAC and others, who are very close to the sort of structure we have, and that can really help you. I also would like to make another comment, which is slightly related to this. I mean, you gave the example of the Operation Windigo, and I'm pretty involved in there. And one of the things we found when we dismantled or tried to dismantle this botnet is that the difficulties were not linked to the activities of the attackers. It wasn't difficult because the software was sophisticated or because the attackers were good. It was difficult because the good guys, so the NRENs and the operators and the ISPs, were really difficult to work with. Right? It's been really, really hard to get to the owner of an IP address, to the owner of the host, and have them to collaborate. So it's not really because of the bad guys we had problems, it's because of the good guys. And that's really where I think we should improve. So
that's certainly true. And so one of the visions of this project is really to help you, especially with contacting the owner of an IP address, because with this central approach, our vision or hope is that you can really push in the data that you have, and because, for example, with the trusted introducer integration, because of the connection between partners in there and their address space, you do not have to do the work of finding the corresponding party, the responsible party for that address space, but you push it in there, and he queries the clearinghouse, and via this link to his address space, he obtains the data directly. So this distribution is taken care of there.
So, thank you. There's another question.
I noticed that your map has had a Switzerland-shaped hole in it. Is there any chance for us poor orphans to participate?
Certainly there is. Come to our website, reach out to us. As I said, this map is I think it's from our description of work, so this is what we planned for at the beginning of the project, and therefore we could only plan for the partners already in there, and planning to set up support centers. And the colored countries are only the ones that we have partners in. But reach out to us. We're welcome.
Is this imagined only at the NREN level, or is that at individual institutions?
I didn't get the first part of the question.
Is this envisioned participation only at the level of the NRENs, or is it can smaller institutions participate?
No, the participation is not targeted, especially at the NREN level. As I showed you on the slide with the partners, we have ISPs in there, we have research institutions there, academia, critical infrastructure operators, and for example, the support centers. The support center in Germany, for example, is operated by ECO, which is the association of the ISPs, more or less. So this is not operated at the NREN level. So not limited to this audience.
Okay, thank you.
There's another question from up here.
Asif from Dante, I have two questions. Is there antivirus companies are part of this project to analyze the malwares that are causing hosts to become part of botnets? And other thing, is this project involved in bringing down the command and control center so that as a quick win, we can bring down the whole botnet quickly down?
We have partners in there doing analysis stuff. We have partners in there from the AV industry, for example, that are quite interested in obtaining new samples that get extracted by different sensors and also doing analysis on this. This is in turn fed back into the clearinghouse. And the second part, the aim of the project is also to take down botnets. But, as you heard in the previous talk, the difficulty in there is that nowadays it's for the botnet owners quite easy to come up with a new botnet and to build up a new botnet. It's, on the one hand, quite difficult sometimes to take them over because of peer-to-peer structures and fallback structures if the peer-to-peer net is not working anymore. On the other hand, it's quite easy with the underground market to just buy a couple thousand of new installs of your botnet. So we think that the important part in here is this larger approach of not only taking down the botnets, but especially going towards disinfecting the clients. Because if you destroy the command and control structure, they are still infected. And I think it was from the configure samples, for example. In the first samples, they already generated I think it was something like 500 fallback domains each day that they tried to contact to re-establish their connection to the botnet. So if you take out the command and control structure, somewhere along the web there's information which is only set up right on time for the bots to access it and to rejoin the botnet. And I think with the latest variant, it was something like 50,000 domains each day. So if you really do not disinfect the clients, you probably won't win that war. And still, the other part of the approach is probably certainly incorporating law enforcement as well, because taking down the command and control structure is helpful in the regard that it costs the botnet owners money or time. So in the moment that they have to deal with our approaches trying to take them down, they cannot concentrate on doing something more nasty with their botnet. They cannot concentrate on introducing something else. But it only costs them time. If we go after them, provide the corresponding, the necessary information via this approach to law enforcement, and you put these guys into jail, that's even better.
Yeah, thank you very much. I would have had a question, and I think I shall ask it anyway, even if we're kind of shortish of time, but still. I haven't heard of any policy except for sort of technical policy enforcement to restrict the access of data to competitors. But there must be a whole can of worms in there somewhere hidden when sharing this kind of type of data somewhere. So where's the small print?
That's certainly true. So as you heard from the previous talk, the nice thing if you ask lawyers is it depends. We have a task in there dealing with this policy stuff and not that much with sharing private data as since we have infections in there, it's not like we have the private data that was exchanged, but in the regard of sharing information about infected machines. And we have an analysis performed on the European level and on the level of 5-6 member states of the European Union. And the outcome of this is, yes, it's difficult, but it's possible. So as long as you make sure that you have some anonymization and pseudonymization in there for the parts where you don't need the actual information on the infection, as long as you make sure that the information is forwarded to the responsible party, the affected party only via the ISP or via the CERT or something like this, then yes, this is compatible with European legislation and the legislation on the national level as far as we looked at up until now.
Okay, super, thank you. So, thanks a lot, Christian. Nice
Thank you.
presentation. So this brings us to the end. Thank you guys very much for showing up here and having this lively discussion. And I think I meant to do a few reminders for you. So fill out the online evaluation form for the sessions you attend. And what else? Vote for the student posters. There are student posters on the ground floor level to be voted with your yellow stickers. And there will be students presenting, I think, their posters later in the coffee break. And what else is there? A demonstration in the demonstrations areas A and B later on this afternoon as well. And then there in the evenings, there will be some BOFs and other meetings that you are free to attend. There's still space, so you could go there. Okay, thanks very much, guys. Thank you.